In this lesson, we're going to talk about how to use the parallelogram method to find the magnitude of the resultant vector. So the resultant vector of these two vectors, let's call this, since these are forces, F1 and F2. It's going to be somewhere in the middle. Now here's how you find it exactly. So the F2 vector, I'm going to draw a parallel vector to it, which looks like that. And then I'm going to draw another parallel vector of the F1 vector, forming a parallelogram. Now, when you draw an arrow from the intersection of the first two vectors to the intersection of the last two vectors, that'll give you your resultant vector. So I'm going to redraw that. So this is the F2 vector. This is the new version of the F1 vector. And this is going to be the resultant vector. We'll call it FR. Now, when dealing with parallelograms, what you need to know is that kappa adjacent angles are supplementary. So these two angles here, they're supplementary, which means that they add up to 180. So this angle is 180 minus 60, which means that it's 120. Now this angle is very important for us to get the resultant vector, because now we could use something called the law of cosines. Now just to recap, let's say if you have a triangle, we'll say this is angle A, angle B, angle C. Across angle A is side A, side B is across angle B, and side C is across angle C. So side C, that's lowercase c, it's equal to, c squared is equal to a squared plus b squared minus 2ab cosine of c. So this should be lowercase ab, by the way. The capital letter represents an angle. The lowercase letters represents the side lengths. So we have F2. F2 is 90. And we have F1. F1 is 80. Those are side lengths. So what I'm going to do is I'm going to make angle C 120. Lowercase c is going to be FR. B, lowercase b, that's F2. And lowercase a is going to be F1. We don't really need angle A and angle B in this problem. Our goal is simply to find the magnitude of the resultant vector. Once we get that, we could use the law of sines to get these other angles if we need it, but we're just going to focus on the magnitude of FR, the resultant vector. So now let's get rid of this. And let's plug everything in. So c squared, which will be the resultant vector squared, is equal to a squared. A is 80. B squared, b is 90. Minus 2ab, so 2 times 80 times 90. Cosine c. Then angle c is 120. So now let's plug this in the calculator. 80 squared is 6,400. 9 times 9, or 9 squared is 81, so 90 squared is going to be 8,100. 2 times 80 times 90, that's 14,400. And then cosine 120 is negative 1/2. So 6,400 plus 8,100, that's 14,500. The two negative signs will cancel, and then half of 144 is 72. So half of 14,400 is going to be 7,200. So we have 14,500 plus 7,200. So FR squared is 21,700. Now we need to take the square root of both sides to get FR. So this is going to be approximately 147.3 newtons. So that's the magnitude of the resultant force vector. That's how you could find it using the parallelogram method.